The Scala programming language is one of the most advanced and sophisticated programming languages used today. It is used mainly in data-intensive applications, but not only. This is not an introductory lecture. We will cover 5 points, 5 main concepts of the language. They are mostly syntactical, but we have a feeling that these concepts are very important to know as they cover some edge cases which might even make learning Scala, which is already complex, even more complex. So without further ado, let's begin. So the concepts we are going to cover, again very quickly because we don't want to waste your time, are generic type erasure, implicit param conversion, conversion from method to function, anonymous functions, weirdos, and for comprehension. Let's move on to the first concept, generic type erasure. Okay, so we will explain it simply with one line of Scala. The one line is a list of int 1, 2, 3. So we have constructed a type, a value which has 3 ints, 1, 2, 3. And this is a list of ints. Now we execute the command as instance of. The command as instance of will be executed in one time, not in compile time, where we ask the JVM to convert it to a list of string, and then we assume we have a list of strings, and if we have a list of string we can take the last one and trim it. A trim is a command we execute on a string, and we have done as instance of list of string. So what is bad with it? Actually it will fail on runtime because generic types are erased. And therefore, although of string, the list of string, the of string or the of int is erased. It is not a string, it is what we have constructed it with. And we have constructed it with 3 ints. And those 3 ints don't have a trim command, and therefore it will fail at runtime. Great. Let's move on to the next item, implicits. The next item is implicit. So I just want to tell you how you use implicits. There are 2 kinds, implicit params and implicit conversion. The first kind, very simple. You see, you have a method, myfunc, it receives 2 arguments. The first one is standard, int, you're just passing an int. But then you pass another argument and you precede it with the word implicit, and pass it a parameter count. Now you can call this function simply with 2 arguments for I and the count, but you can also pass the second one because you defined it as an implicit value. Let's see how it is used. So first you can call the function as usual with the 2 parameters, but you can also define implicit. Here you are using again the implicit keywords. Note that you used it before as a parameter identifier to the function. You define the parameter count as implicit. This parameter implicit, it can be passed implicitly, but you defined it again as an implicit value. And when you define a value c equals 3s and precede it with the word implicit, this means that the compiler will treat this type, it's based on the type of the parameter, as an implicit int which hangs around, and whenever a function is asking for an implicit of type int, it will try to find it and pass it. So we use the word implicit in 2 places. In one place is the definition of the function, where we define the parameters implicit. Another place we defined a value as implicit. We use the word implicit twice in this case. Okay, let's move on to the second usage of implicit. The second usage in this case is of implicit conversion. So here we simply defined a method and we use the keyword implicit again. We put the word implicit before the def. So we tell the compiler, please look, this method is an implicit conversion, which means you can find this method implicitly whenever I supply you with a string, return me an object of type name. And what can I do with it? What I can do with it is I can define a value of type name and put in it equals and assign to it a string. And because I have defined an implicit function which receives a string and returns a name, it's like a constructor, receives a string and returns a name, I can just assign the hello to the name. The compiler will look, do I have any implicit conversion from string to name? Yes, I do have. So convert it implicitly. It's very hidden. I don't really recommend using these features heavily because it's a little bit, as you see, it's magic, okay? So it's implicit and it's some kind of magic that the compiler does for us. Okay, let's move on. Let's convert a method to a function. Okay, so I have a method repeat. It receives two parameters, string and int, and it just concatenates the string as many times as I have placed the int. So why is this a method and not a function? It's a little tricky, but in general you can think of a method as something that belongs to an object, and to a function just something that belongs to itself. It's just a function. It doesn't need to belong to an object. Okay, so we write here val func equals repeat and underscore. Why underscore? Because we don't really supply the types, and because this is the syntax. This is the syntax to assign the method repeat to the function. And we didn't note that we didn't specify any type parameters to the func, to the val func. We didn't specify any type parameters, and this is why we need the underscore. Okay, if you do supply the type parameters to the func, you know it's from string and int into a string, then you will see in the next example that this underscore will be less and less used as much as you supply more and more type parameters. For example, here we have the same repeat method, and we again assign the method repeat into a function. But note that here we say that function is of type string int to string, and therefore we don't need to use the underscore. So the more we provide types, the less we need to provide underscore. Why is all this thing even important? It's important because Scala is not that simple to learn, especially when you get involved in this kind of stuff, and you see it's a little bit tricky. You need to remember, when do I add this underscore, when do I don't need to add underscore, when do I have this implicit, oh, there is another implicit overriding this one, the compiler doesn't work. So there are implicits and underscores which convolute your syntax, and I recommend to use it very carefully. Very carefully, because another programmer which looks at it, it's not easy to read, and the main purpose of writing software is for reading them, and reading should be simple, so you should focus on simplicity. But this you need to learn these concepts if you are dealing with Scala, because these things are used, so you need to know them. At this point I want to tell that I took these ideas from the presentation from the great Il Hanoi, one of the creators of Scala.js. He has a blog post about Scala words. If you want to read further, then please take it from there. I got the inspiration for the ideas and took even the examples from this blog post. I highly recommend you to read this guy and follow him. Okay, so another example where we assign the method repeat to a function. In this case, as you see, as we said, the less we explicitly mention the types, the more we need to use the underscores. This is the syntax. So in this case, we do val func equals repeat, and as we didn't define any types any type parameters to the function, we need to tell the Scala compiler underscore inside the repeat, meaning take the repeat, take its types and put them in and just assign it to function. Okay? Okay, let's move on to the next item. The next item is that is about anonymous function or lambdas or whatever you like to call them. Scala is a functional programming language, combines both object-oriented practices and functional. And this means you treat functions as first-class notations, and in this case we have some data structure and we apply a function on it. Which function do we apply to it? We apply the function multiple by 1. You see here x1, I meant multiple. So you take x times 1 or plus 1 or whatever. I missed the plus. Okay, so you take the sequence of 1f2 and you call the function map and you pass it a function. The function is from x to x plus 1. And this is very simple. Okay, we just wrote the function inside the map. But the rot here is that if you had a sequence of tuples, not a sequence of just two plain numbers, then you could expect that you should have write according to the above just, okay, my map function would be from x, comma y tuple to x plus y plus 1. But this would not work, this would not compile, and this is another case which can mix you up while you write Scala programs, because here you need to remember another thing about the syntax. And another thing that you need to remember is that if you use it for tuples, then you need to add these curly braces and the case. And you say curly braces, case xy is 2x plus y plus 1. Okay, so remember, if you just have a plain type, then you just write the function. But if you have a tuple, add the damn case. Okay, next item I want to talk about is about for comprehension. Scala programmers will know this by heart. If you don't, I personally needed to invest some time in order to understand this, then I want to mention it. So here we have a for comprehension, and what the question here, which is usually asked many times by Odersky and others, is what would this for comprehension translate to? Because it's a syntactic sugar. What would this translate to? It would translate, if you look below, into some hierarchy of flat map and map. Okay, ignore the foo equals 5. It would translate into flat map and map. Now the question which you can ask is, so it's like a loop inside the loop inside the loop, okay? The question which you might, nested loops, but it's pretty sequential. So the for comprehension is very easy to read. The translation is a bit tricky. Why flat map and map and not map and then flat map, or map flat map and then map? Okay, now the story goes like this. Imagine you have at least a few workers. A few workers on an assembly line. Okay, so each worker receives some item, does something good to it. Let's say it receives a car, it adds the wheel and passes the car to the next worker. The next worker takes another part of the car, and then let's say it's coloring it and passes it to the next worker. The next worker installs the alarm and finishes with the car, packages it and ships it to high consuming countries which consume a lot of cars. And okay, so we had first worker, on assembly line, a second worker, and the third worker. Now, we don't want the first worker to take the car, add the wheel, package it, give it to the next worker. The next worker will need to unpackage it, do his magic, package it again, bring it. Okay, you see, we're wasting time. Each worker is doing his operation, packaging the item, and giving it to the next worker, which will unpackage it and then repackage and give it to the next worker. We want only the last worker to package it. So we use a trick, and this trick is not trivial as I see it. We use first flat map. Now what does flat map say? It's very almost identical to map with some big difference. The big difference is that you tell flat map how to package your object. In map, it packages it automatically for you. So in flat map, you tell your function that you supply to flat map will tell how to package the object. So in this case, we tell it how to package the object. Let's say x flat map I, we tell it inside the I and the arrow, we actually tell it how to package, and notes that we don't tell it how to package the object, but at the end of the nested flat map, we have map, and map automatically packages it. So this means that each flat map says, okay, you know what, I'll package it, because the method signature of flat map forces me to tell you how to package the object. But actually I won't really package it. I will just transfer this obligation of packaging it to the next method, and the next flat map also say, okay, I will tell you how to package it, but we will pass it to the next function, and finally the map arrives and map packages it automatically. Okay, map automatically packages it. You don't supply it how the packaging system works. And this is why we have flat map, and map, because each assembly line worker passes the responsibility of packaging the item to the next assembly line worker, and each assembly line worker is a flat map. The last assembly line worker is a map, and the last assembly worker responsibility is to repackage the item automatically. So this is the reason why for comprehension translate to flat map, map. Okay, the next item I want to cover is that in for comprehension, as Il Hanoi mentions in his great post Words of Scala, you could have expected that you could be able to write print line something, but you can't. It won't work, it won't compile. Okay, and this is another thing you need to remember when you program with Scala, alongside the other things you need to remember. Not that I'm against Scala, I love Scala, but there are a few things you need to remember which are pretty much arbitrary. And this part I less like, okay? So you just need to remember that if inside the for comprehension you need to do some operation like print and ln, or I think also for each, or something that does not consume the previous variable and passes it, then you need to do underscore equals println high. Why? Arbitrary design decision. This is how it was designed, and you need to remember this. Not trivial, another thing to remember, but this is why we are doing this presentation. Remember, we are doing it in order to cover a few concepts, a few glitches, as Hanoi discusses in his great post. Okay, with that we conclude the presentation. If you will look at the channel, you will see that we have a few more presentations about philosophy, history, programming, and we plan to add more about math, physics. If you are interested in any topic or have any comments about this one, or have any comments about how I present the stuff, please do comment, and if you liked it, please click the like. If you unliked, please click the unlike, and I hope to hear from you, and please give me feedback. Thank you very much, and see you in the next lecture.